Good afternoon, my dear children. Welcome to mathematics class. Today I'm going to start the new chapter, that is chapter 4, pairs of linear equations in two variables. And you all know that the content is reduced due to this corona this problem. So you all know that the how much the content is reduced. Even then, if you don't know, no problem. Whatever the videos are sharing, if you prepare that content, that is enough for your board exam. Okay. So let us move on to the content. Linear equations in two variables, that is x and y, and here 3 and pi are the constants. Okay. Now the pairs of linear equations in two variables, the main key concepts which you are going to learn in this chapter are definition of linear equation, pairs of linear equations in two variables, means how to write the general form of the pairs of linear equations in two variables, consistent and inconsistent equations, methods to solve the pairs of linear equations, and solving to pairs of linear equations. So first, we'll move on to the first part of this key concept, that is definition of linear equations. Any equation of the form ax plus by plus c equals to 0, where a, b, c are real numbers, and where at least one of a or b is not equal to 0, and a square plus b square is not equal to 0, then we call it as a linear equation in two variables. Okay, so here what are a, b, c? The a, b, c are the real numbers, and once the linear equation two variables is given, you must check the square of a and the square of b and add both of that. That should not be equal to 0. Next, general form of linear equation in one variable, which is ax plus b equals to 0. This is very, very important for the objective. General form of linear equation in one variable is x plus b is equal to 0. The system of pairs of linear equations in two variables are how to write generally the two linear equations, the pair of linear equations. A1x, here 1 is nothing but suffix children. A1x you should have below this A. A1x plus B1y plus C1 equals to 0. A2x plus B2y plus C2 equals to 0. Where A1, B1, A2, B2 and C1, C2 belongs to R. R means real numbers, such that A1 square plus B1 square is not equal to 0 and A2 square plus B2 square is not equal to 0. So these are the two general forms of the linear equation, pairs of linear equations. Now, pairs of linear equations can be represented by and solved by in two methods. The first one is graphical representation and algebraic method. So in these two ways, we represent as well as we solve the pairs of linear equations into variables. So in graphical representation, we have the three conditions are there. First, how to represent the graphical representation of the two linear equations as well as how to solve it. That means we must plot at least the 2 points you have to consider for each linear equation in two variable, and you have to plot those 2 points on a graph sheet, so that then after plotting the 2 points on a graph, then for the first line as well as for the second line, then you must check these are three cases are there. You must check these three cases. The first case, if the two lines intersect at a point, then we say that they're intersecting lines and they have a unique solution. Unique means what? They have only one solution. The two equations are here we say that these two lines are consistent. It means when you plot the two straight lines, two linear equations in two variables on graph, then if you observe it that the two lines are having a unique solution, then we say that those two lines are consistent lines. Then are an intersecting lines as well as consistent. The second one, case 2. If the two lines coincide, then there are infinitely many solutions, and in this case, we call the two lines as dependent or consistent lines. Here we have they are consistent and dependent lines, and we call them as coincident lines. The first one is intersecting lines. When you get a unique solution, the two lines are intersecting at a point, then we have a unique solution, one common one solution only. Then we call those two lines as intersecting lines, and they are called as consistent lines. Here, if these two lines are coincide each other, then we say that those two are coincident lines and they have infinitely many solutions, and we call them as dependent or consistent lines. Now, case 3. The two lines are parallel. If you get a parallel lines after plotting the points of the two lines, then if you get a parallel lines, then we say that they have no solution for those two lines, and we call them as inconsistent lines. So we have consistent and inconsistent lines. Inconsistent lines, we have intersecting lines as well as coincident lines. These two will comes under consistent lines, and whereas inconsistent lines will have only the parallel lines. Now, you see the condition here. Suppose these are two linear equations. That is, first one is x minus 2y equals to 0 and 3x plus 4y is equal to 20. These two have plotted by taking the 2 points of each line and plotted on the graph sheet. You see, observe here, these two lines are intersecting at a point. So at which point those two lines intersecting? 4 comma 2. So that means it has a unique solution, means only one solution. These kind of lines are called as consistent lines as well as intersecting lines also. Now, see the observe the second graph. The two equations are linear equations in two variables. Both are plotted again by taking the 2 points of each line and plotted on the graph. Then you observe here, we got the two parallel lines. That means we don't have any solution for these two pairs of lines. That's why these are inconsistent lines. We call them as inconsistent lines. So inconsistent lines comes under parallel line. They have no solution. Now observe this figure here. All the three cases are given here. The first case, the two lines L1 and L2 are intersecting here at a point P, X, Y. So they are intersecting lines and consistent lines also. Here, these two lines are parallel, L1 and L2 here parallel lines, and they have no solution. Here, only unique solution. That's why they are intersecting lines. Then the third case, you see there, one among the other, both the lines are there, but one among the other. So they are called as dependent or coincident lines. And these are also consistent lines. This is inconsistent and this is again consistent lines. So very, very important for the objective children. So two lines have unique solution, then they are called as, the options will be given there. If the options are given intersecting, parallel, coincident means you must write intersecting, and if it is given consistent or inconsistent means you must write consistent. Okay, children. Now move on to the next set of this. That is, if let a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals 0 form a pair of linear equations, then I will show you one table here. After this slide, I'll show you one table. What it is going to happen when these two pairs of lines are considered, then what is going to happen when, means how to recognize whether directly after given the, after observing, after considering, or after taking the two lines or pairs of lines, how to identify whether they are parallel or intersecting or coincident lines. They have three conditions are there. That is, algebraically, we can easily identify whether they are coincident, I mean intersecting or parallel lines. In previous one, you observed there is a graphical representation, how to observe, how to find, how to recognize, how to represent the two lines, and as well as how to solve whether they are parallel or intersecting or coincident just by seeing the graph. This is algebraically. The pairs of values of the variables x and y for which the pair of equations is satisfied, we call them as solution set or solution. Here I am saying it has unique solution. That means solution is nothing but that solution. That means that pair that x and y, when you substitute that x and y values in the equation, linear equations, it which satisfies the linear equation. It means the point which satisfies the linear equation, that is called as solution set of the linear equation. Now move on to the table here. See children, very, very important table for the objective part as well as even for 1 mark and half mark questions also will get based on this table. Very, very important. See the condition. Suppose there are two equations. I already said a1x plus b1y plus c1 equals to 0. and a2x plus b2y plus c2 equals to 0. These are the two linear equations in two variables, then if a1 by a2, the ratio of a1 and a2, that means the coefficient of first x coefficient and second line's x coefficient, the ratio, as well as the ratio of y coefficient of the first line and the ratio of the y coefficient of the second line, if these two ratios are not equal, then they are intersecting lines. Remember, children, graphically what we have considered there, we have taken there the unique solution there. So here, when the ratio of a1 by a2 is not equal to b1 by b2, then we say that they are the intersecting lines and they have a unique solution and they are called as consistent lines. Now, second condition, a1 by a2 is equal to b1 by b2, which is not equal to c1 by c2. C1, C2 are what? Constants. Which is not equal to C1 by C2, then they are parallel lines and they have no solution. And they are called as inconsistent lines also. Now, the third condition is A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Then they are called as coincident lines or dependent lines. They have infinitely many solutions. So intersecting lines have how many solutions? They have only unique or one solution. Parallel lines have dash solutions, no solution. And coincident lines or dependent lines have dash solutions, infinitely many solutions. And algebraically, you have to consider in this way. That means you must take the coefficients of x, that will be a1 and a2. The coefficients of y will be b1 and b2, and the constants will be C1 and C2 for the two pairs of linear equations. So by seeing this, by taking the ratios, and immediately you can identify whether they're intersecting or parallel or coincident lines. So children, I hope you might have understood the today's content very well, children. Please once again watch the video and try to understand how to identify graphically whether the given pair of lines are intersecting, parallel and coincident lines. Similarly, how to recognize or how to identify the given lines are parallel, intersecting or coincident lines algebraically. So please practice once again and try to write the sums based on this one. You only take your own pairs of equations, two equations, you only make it. And from that, you take the coefficients of x of the first equation, coefficient of x of the second equation, and take the ratio. Similarly, coefficient of y of the first equation, coefficient of y of the second equation, and take the ratio and equate them. Just see that if you are not getting both the ratios equal, then we say that both are intersecting lines. In this way, you can easily make it out. So I hope you might have understood today's content very well, children. Thank you very much, and thank you one and all.